Welcome everyone to this video on graph interpretation in section 1 of the UMAT exam. Now this video is the final in the section 1 set. You can see it right down there in the bottom. It's one of two under the data interpretation subsection, and a lot of the tips and tricks for dealing with these questions were dealt with in the table interpretation video. So all the stuff you learned from that video is still applicable to this one. And if you haven't seen that video, that's right, I'll go through it again as we work through the various questions. So we'll get started with question 1. You can see a graph there where there's quite a bit going on. So I'm going to begin by just breaking it down into its various components. So remember, with any graph or any table for that matter, the first thing to do is either read the title, or if there is no title, as is the case for this one, look for either some description underneath or to the side, which gives you information about what's being shown. So in this case, the figure 1 here at the bottom will help guide you working out what everything is showing. So you can see the first thing it's showing is new cases of lung cancer per 100,000 people. So I'm going to underline that in red. Now if we look up at the graph itself, which part of the graph is dealing with that is the question we have to ask ourselves. So new cases of lung cancer. If we go to our key, we can see that this bit here is again new cases of lung cancer, and it shows us that that part is shown by the grey part of the graph, which must be the bar graph. So the bar graph shows the new cases of lung cancer. Now, which part of the graph do we read that off? Well, again, you can see on the left-hand side, new cases of lung cancer per 100,000 people. So everything circled in red belongs together. What it means is if you want to find out information about how many new cases of lung cancer there were per 100,000 people in a given year, just read the bar graph off the left-hand axis. That's all that's saying. Now if we keep going and look at different parts of the graph, I'll just change color pens to illustrate a different part of it. The next thing we can see in the figure is total expenditure on cigarettes in terms of billions of dollars. So again, go up to the graph and see where else you can find that. You can see here total expenditure is given, and you can see from the key that it's the line. So the line graph in the graph here is the bit that gives us the information about total expenditure. So I might just make a little mark there on the line graph just to say that this is the bit that belongs with the blue group, which is total expenditure. And where else do we see total expenditure on the graph? Well, it's on the right hand side here. So what that means is we have to read the line graph off the right hand axis, off the numbers we have down here. So that's the second part. The final is just that final bit of the figure 1, which is saying the proportion of new lung cancer cases which are associated with smoking as a percentage. And all of this is in Australia, of course. So where do we see that on the table? Well, the units for this are percentages, and the only percentage I can see up here is just above each of the bar graphs. You can see there's nowhere else in the key or on the axes that mention percentages or anything about the proportion of new cases associated with smoking. So we have to assume that's just to do with the percentages on top of each of the bar graphs. But of course, they are separate from the bar graphs themselves. So the bar graph shows the new cases, as is shown in red, and the percentage on top is a different concept. That's showing the proportion of new cases associated with smoking. So we've got 3 separate ideas, all shown on the one graph. Now we just have to go through the answers and work out which one's best. So which of the following can be concluded? Option A, there were more new cases of lung cancer diagnosed in Australia in 02 than 03. So we're dealing with new cases of lung cancer, which in 02 and 03. So that's the bar graph, because we know that this is the new cases there in red, and as we can see from our key, it's the bar graph we're interested in, and we're looking at 02 and 03. So we're looking at the bar graphs in 02 and 03. And that looks pretty good because you can see that the number went down. So it does appear that there were more new cases in 02 than 03, except that the one trick here is that the bar graph is showing the rate. It's a proportion per 100,000 people, whereas the answer here, option A, is talking about a raw number of cases. So it's that idea of raw number being a different concept to proportion or rate. So the reason why it's wrong, in short, is if the Australian population decreased significantly between 02 and 03, even if the rate of new diagnoses went up, the raw number of new diagnoses would have gone down. That's why you can't conclude A, and why A is incorrect. So again, that idea of raw number versus proportion is very, very important. Option B, the highest total expenditure on cigarettes in Australia in the 2000s was in 2005. So we're now looking at the total expenditure, which remember is the blue part of the graph, which we've circled, and that is the line graph. So this part may look, this option may look pretty tempting, because you can see the line graph does peak here in 2005. The only trap with option B is that it says in the 2000s, and we've only got 8 years here. We're missing 2000 and 2001. So we can't conclude that that was indeed the highest figure for all of the 2000s, because we're missing a couple of years. That's the little trick with option B. Option C, the rate of new cases of cancer. So again, we're looking at the bar graph. In 2005 was higher than in 2006. So we can see here, we're looking at the bar graph, and it looks as though 06 was actually higher than 05, which is why that one's wrong. The trap here is that some people read the number above, the percentage, and think that because that percentage is higher in 05 than 06, then option C is right. But remember, that's a completely different concept. That's the green parts we outlined, which is to do with the proportion of new cases associated with smoking. So it's a different concept altogether, and that's why option C is wrong. And so finally D, 82% of lung cancer diagnoses in Australia in 07 were associated with smoking. So this is the green part of the graph, the proportion that are associated with smoking. And remember, that is given by the percentage above each of the bar graphs. So in 2007, we can see that percentage given here was 82, and that is in keeping with option D. So based on that and the fact that A, B, and C were all wrong, we can say with confidence that option D is the correct answer. We'll do question 2 now as well. So which of the following can be concluded about total expenditure on cigarettes in Australia? So now we're just dealing with the line graph, which remember we have to read off the right-hand side. So the option A, the sharp increase observed between 05 and 06 was due to the introduction of plain packaging. That should say the sharp decrease. The sharp decrease observed between 05 and 06 was due to the introduction of plain packaging. Either way, you can't make any conclusions about the reason for a particular trend in a table or a graph, unless you have some source of information as to why something happened. If you're just given a selection of numbers and figures, you can't say why something happened. So A is not correct. Option B, it will decrease between 09 and 010. So again, it's asking us to make a prediction about the future, which we can't do. We can't say what will happen with any certainty. So that can't be correct. Option C, it increased by 0.2 billion between 06 and 07. So we're looking at the line graph and reading off the right-hand side. So in 06 it was about 3.8 billion, and in 07 it was about 4 billion. So that does seem to be an increase of about 0.2 billion. And so option C is looking pretty good at this stage. Just check option D. Less cigarettes were purchased in 06 than in 05. Well, again, that probably is correct, because you can see there's a sharp drop here between 05 and 06. So there probably were less cigarettes purchased in 06. But we can't be sure, because the graph is showing the expenditure in terms of money, not the actual number of cigarettes. So if there was a change in the price of cigarettes, if cigarette prices dropped dramatically, say, then it's possible that still more cigarettes were purchased in 06, but the total expenditure still went down. And for that reason, the answer here is option C. Question 3. This one deals with a survival curve, which is a type of graph you may or may not be familiar with, but I think it's a good one to include in this video. The basic idea of a survival curve is it shows the survival, and therefore the death, of patients over the course of time. So it's quite a morbid concept, but it's also a fairly simple one to get your head around. In this particular case, we're looking at the 24-month survival curve for patients based on various chemotherapy regimens. So we can see the various chemotherapy regimens are given here in the key. So each color line represents a different type of chemotherapy. On the y-axis we have, as always, time. So in this case it's months post-diagnosis, which is why it's, as we can see from the title, a 24-month curve, because we have up to here 24 months. And on the x-axis we have the percentage survival. So for that reason, survival curves always start up here with 100% because all patients are initially alive. And as they start to pass away, that curve drops off. And you can see how you can track it over each month for each of the different regimens. So a curve that drops steeply like this indicates that a lot of patients are dying off quite quickly, whereas a more gradual curve like this would indicate better survival. So if we're looking at the best chemotherapy regimen in terms of survival, we're looking for the curve which is kind of on top of the others. In other words, it's decreasing more gradually. So if we look at the question, it's which of the following was the best chemotherapy regimen for patients included in the study? The first issue I have here is the wording of the question itself, particularly the word best, which is a very subjective term. So the question hasn't asked you which of the following was the best chemotherapy in terms of survival. It's just said best. So to me that's a bit vague because one regimen may have the best survival outcomes, but it may also come with a very heavy side effect burden, for example. So for any given patient, they may not want to survive a little bit longer if it means a far worse quality of life. Now you may think that's a bit or reading a bit too finely and reading a bit too much into it, but given we have this option D here where it says we cannot conclude this from the data, you need to look to see if you can actually conclude this question from the data, or if we need more information such as side effects and other things. That's the first issue I have. Just the word best is very subjective and maybe can't be concluded just from the single table or single graph above. The other issue is that even if we were to take this question as just dealing with purely survival and the best chemotherapy regimen for survival, there is no clear winner from this graph. You can see initially the green graph, which is the chemotherapy with TMZ, seems to be the best in terms of survival because it's on top here. But around the 12-month mark, the pink, which is the chemotherapy without TMZ, tends to take over. And you can see here from about 18 months through to 24, it becomes the best in terms of survival. So what that means is if you're on the green chemotherapy, the one with TMZ, initially you have a better chance of surviving the first 12 months than someone who's on the chemotherapy without TMZ. But after that, the people without TMZ tend to have a better odds of surviving. So there's no clear winner out of those two. You have a greater chance of dying earlier if you're on the chemotherapy without TMZ, but you also have a greater chance of living longer. So it's not a clear-cut winner. There's not one graph which shows an obvious benefit over the others. And so because of those two reasons, both the vague and subjective nature of the word best, and also the fact that there isn't really a clear winner over the whole time course here, I think D is the best option to this answer. So don't be afraid to go for the answers which say you cannot conclude this from the data. They're not a cop-out. They can be right. Not always, but they can be right. So do have a careful look at these questions if that's the case. In this case, I'm going to say that the answer is D. Just one more question now based on the same graph. The new one is, at what month post-diagnosis can it be said with certainty that more than half of participants in the overall study had died? So we're looking at the point at which more than half of participants overall had died. So that's the point at which overall the survival curve drops below 50%. So I'm going to sketch up a line coming out from 50% here, just to show, or better show, where it intersects the various curves. Now you can see that we've got three different chemotherapy groups, as we established before, and as we can see here from the intersections, they have different points in time when, out of that cohort, the more than half of participants have died. So for the pink group, that point comes at about the 5-month mark, we can see. For the blue group, it's about 6, and the green is about 7. So if we're looking for the point at which overall, out of all three groups put together, more than half of participants had died, it may be very tempting to just think that assuming each of the three groups is roughly the same size, we can just average out those 3 time points to come to an answer of 6 months, as we can see here in the middle. But the trap in this question is it's saying, at what point can it be said with certainty that more than half of participants had died? So with certainty means that you have to consider the most extreme example that you can imagine, basically. So let's imagine for a minute that instead of there being 3 equal groups in terms of the number of people, that one of these groups, let's say the green group, had far more people than the other two. So let's imagine a scenario, say, where the green group had 1,000 participants and the pink and the blue had about 10 each. So very unrealistic, but let's just imagine for a minute. If that was the case, at the 6 month mark, you can see that out of the, in the green group, which we're saying had now 1,000 people in it, the survival point, the survival percentage is about 55%. So there'd still be about 550 people in that group still alive. Now the other two groups are pretty negligible because we're saying that there are just 10 people in those two groups in this example. So at the 6 month mark, we can say that maybe 5 people in the blue group are still alive, and maybe 4 in the pink. So in total, that's about 560 people alive out of a total of about 1,020. So that's still more than half. And that's just an illustration of how if one group is much bigger than the others, it distorts the overall data because the weighting of that one group pulls the overall results towards it. So what that means is if we want to know the point at which overall more than half of participants had died with certainty, we have to say 7 months, because if this green graph here and if the green group was weighted much more heavily due to it being very big, then the answer would be closer to 7. So in this case, the answer is C. Question 5. This is actually quite similar to questions 1 and 2, so a bit of revision already. You can see again we're dealing with smoking rates and lung cancer rates in the UK. So always begin with the title if the graph has one. And in this case we can see we're dealing with two different concepts, smoking rates but also lung cancer rates, and it's just in the UK. So looking at the graph itself, there's kind of a key up the top here. You can see on the left hand side there's smoking rates, and we've got a few dots next to it which indicates that smoking rates are shown by the dotted graph in the table. In the graph. Now there's two of those. You can see that the blue corresponds to men and the pink to women, and it shows how smoking rates have changed over time. Now the other trick here is to pick up on the fact that there are again two axes with numbers down them, and we have to work out which one to read off for smoking rates. The key is to look at the units. So the units here are percentage of adults who smoke, and of the two axes, the one with percentages is on the left here. So to work out the smoking rates, you have to just look at the dotted graph reading off the left-hand side. Now the other part of this is the lung cancer rate, as shown at the top right, and you can see here that the solid line shows that. Again, there's one for men, one for women, and we'll read that off the right-hand side, presumably, because it's the only remaining axis to read it off. And this is in terms of cases per 100,000 people. So it's a rate rather than a raw number. So if we go to the question, which of the following can be concluded? Option A, between 1975 and 2010, the rate of lung cancer in men in the UK approximately halved. So we're looking at the lung cancer rate, which is the solid line, and we're looking at the blue line because we're looking at just men. Now between 75 and 010, let's have a look at the numbers. So in 75, the number was, or the rate rather, was about 115 to 120, let's say, based off reading it off the right hand side. And in 2010 it was about 55 to 60. So I would say that's approximately half, and the wording is very good. You can see all the key things are in option A here. We've got rate, lung cancer, men, UK. It's all in keeping with the graph, and the wording of approximately is very good too because it's nice and general. It's not saying exactly, it's just saying approximately. So at this stage A is looking pretty good, but let's evaluate the other options. So with B, less people in the UK had lung cancer in 010 than in 1975. Already there should be alarm bells going off because remember this graph just shows rates and proportions, whereas this option here is talking about the number of people. So even though the lung cancer rates overall have probably dropped if we kind of average out those two graphs, we can't say anything about the number of people because the population number over that course of time could have changed quite dramatically. So again, it's that idea of raw number versus proportion or rate or percentage. Option C, in 2010, more women in the UK had lung cancer than were smoking. Again, there's a problem there because we're dealing with the raw number of women, which isn't shown in this table. And it's asking us to compare kind of the smoking rate shown by the dotted line with the lung cancer rates shown by the solid line. But as you can see, the numbers, or rather the the representation here is using completely different units. We've got, on the one hand, percentages of adults, and on the other hand, we've got cases per 100,000 people. So it's pretty hard to conclude that. Option D, just finally, in the future. So already we're thinking probably not the right answer because you can't make predictions about the future. The smoking rates for men and women will converge. Well, it looks like they may be converging, but again, no predictions about the future can be made. So the best option out of the four would still be option A. Just one more question based on the same graph, and it's pretty similar to the one we had 2 questions ago, where we were asked about the first point in time at which more than half of the participants in that study had died. Same concept here. The question is, what is the first point at which it can be said with certainty that less than half of people in the UK smoked? So we've got a few different options here. Looking at the graph, we've got smoking rates shown by the dotted lines, and there are two different lines. We've got one for men and one for women. Now, the temptation again, particularly given we would normally assume that men and women are present in roughly equal quantities, is that we would just average out the two lines and find the point where the average roughly crossed 50% and dropped below 50%, given in this question we're looking for the point where less than half of people smoked. But remember, you can't make any assumptions about the number of people in each group. So even though it may look as though somewhere around here in the 60s, the average of the two lines would be below 50%, you have to wait for the first point at which both lines are completely below 50%, which would be about here. This is the first point where, regardless of how many men and women made up the population, the overall rate would definitely be below 50%. And so we have to just look at what point in time this was, and it corresponds to about 1971. So that would be the answer. The answer would be C. Question 7. As always, just begin by having a read of the title. So we're looking at the mean writing score by ethnicity and socioeconomic status. So obviously the graph is showing some kind of score relating to writing, and they've broken it down and presented it based on both ethnicity, which is shown by the different colors here in the key, but also socioeconomic status, which is shown here with low, middle, and high. So each of the different clumps of 4 bar graphs represent a different socioeconomic status. The only other trick here really is the vertical lines you can see on top of each bar graph. And as it says at the bottom here, they represent the 95% confidence interval, which is a concept we went through in the previous video. And what all it means is there's a 95% chance that the results shown by each bar graph lie within that line. So if we pick a particular group, let's say the Hispanic group in the high socioeconomic group, the best estimate for their writing score is shown by the bar graph, which is about 48 to 50. But you can see the confidence interval ranges from about, let's say, 38 to 60. So there's a 95% chance that the true result is somewhere between 38 and 60. That's all that means. If we go to the question now, which of the following is the best conclusion? A says that in all ethnic groups, the mean writing score increased as socioeconomic status increased. So what we have to do there is go through each of the 4 ethnic groups and just track across the socioeconomic groups and see if they increase. If we start with the blue, the Hispanic group, just focusing on where that bar graph is, we can see that there isn't really appreciable increase, maybe a slight increase between medium and high, or middle and high, but really the 3 blue graphs are all about the same height. If we go to the maroon graph there, the Asian group, you can see it actually goes down between low and middle. So already I'm thinking probably not the best option. Already there are some flaws here. For option A to be right, you'd really want for every ethnic group the bar graph to be increasing in height as you went along, but that's obviously not the case. With B, there was greater variation between ethnic groups than there was between socioeconomic groups in mean writing scores. So it doesn't sound like the greatest option initially because there's a lot going on and it's asking us to make a pretty big conclusion about whether the ethnicity or the socioeconomic status makes the bigger difference. But if we have a look at the graph here, and again, just track each ethnic group as we go across to have a look at that. The ethnic groups seem to remain pretty much the same. In other words, the Hispanic group remains the same across all socioeconomic statuses. Likewise, the Asian group doesn't change too much. Maybe a difference of about 5, maybe a maximum of 10 between these two. The black group, likewise, very similar, and the white group, very similar. So the biggest change we can see with respect to within ethnic groups is maybe the Asian group here, where the jump from middle to high is about 5 to 10, based on the mean writing score here. If we look between ethnic groups, though, we can see that there are much bigger differences. Here in the low socioeconomic group, we can see that there's a jump of about 15 between the Hispanic and the Asian group. Likewise here, about 15 again. So there do seem to be bigger differences between ethnic groups than between socioeconomic groups. So B is actually a reasonable answer. It's the kind of answer where you wouldn't go for it straight away, but you need to evaluate the other answers to see whether there is a better option. So we'll do that now. Option C, there are approximately as many people who could write as couldn't. Now the trick here is that, sure, on average, all the graphs together would average about 50%, but the mean writing score doesn't necessarily mean whether people can write or not. It may be totally unrelated to that. So that's the trick there. That's why C can't be correct. And D, there's at least a 95% chance that Asian people of middle socioeconomic status have a higher mean writing score than white people of a middle socioeconomic status. So we're looking at the middle group here, and we're comparing the Asian group to the white group. So the maroon graph here to the orange-yellow one there. Now, even though the bar graph shows that the Asian group have a higher mean writing score than the white group here, as we can see, the confidence interval for the Asian group crosses over and goes below the bar graph, and indeed the whole confidence interval for the white group. So we can't be 95% sure, because we can see that the 95% confidence interval here contains within it the result for the other group, the white group. So for that reason, D can't be correct. And so I think the best answer out of all four here would still be B, even though it's not definitely obviously correct. I think we've ruled out the other three options sufficiently to say that it's the best answer. So I'll go for B in this question. One more quick question based on the same graph. The new question is, assuming the bar graphs are accurate, so in other words, we're going to ignore the confidence interval lines just for a minute, which ethnicity had the highest overall mean writing score? Now, if you look at the answers, we can see that we've got Asian, black, white, and option D is there is not enough information to draw a conclusion. So that's an important observation, because if option D was Hispanic, say, then we would know that one of the four answers would be correct. In other words, we could definitely conclude that one of the ethnicities had the highest overall score. But when you have option D, there is not enough information here to come to a conclusion. You have to first work out whether you can give an answer before you work out what that answer is. So in other words, you have to work out if an answer can be given or if this question isn't valid. So first of all, just check the wording of the question. It looks pretty good to me. We can see it's asking about the ethnicity with the highest overall mean writing score. And that wording is very consistent with the graph here. You can see in the title, mean writing score by ethnicity. So, for example, if one of these words was a bit wrong, if it was the highest overall mean reading score, then you could go straight for D. That's just the importance of identifying that this answer is there and seeing if you can find a quick answer based on that. But at this point, it does seem to be all pretty consistent with the graph, so I'll have to keep looking. Now, with the graph itself, if we're looking for the highest overall mean writing score, the challenge there is that for each of the four ethnicities, they're represented in three different bar graphs. You can see if we pick, say, the Hispanic group, there's three separate bar graphs, one in the low, one in the middle, and one in the high socioeconomic groups. Same for all ethnicities. There's three different ways they're represented. And we're being asked for the highest overall score. So we're being asked, when you combine all these three groups together for any given ethnicity, which is the highest overall score? Now the challenge there is that we don't know the raw number of people making up each of the bar graphs. We don't know if it's an even spread or if one of the particular bar graphs has a disproportionate number of people in it. Now, ordinarily that would cause a problem with working out the overall mean writing score, but in this case we're just being asked for the highest one, the highest overall score, and as you can see in all three of the socioeconomic statuses, the Asian group is the highest score. You can see here in the low, and in the middle, and in the high. They're the highest of each socioeconomic group. What that means is, regardless of how many people and what proportion of people are in each of the three bar graphs that correspond to the Asian population, it doesn't really matter what that proportion is or how they're distributed, when you average it out, when you work out the overall score, they will be higher than the other three ethnicities, because in all three cases, their overall score is higher than the other three ethnicities. So if, for example, let's say in the high socioeconomic status group, the Asian group here, where the mouse is actually stopped a bit below the yellow bar, which represents the white population. If that was the case, you would have to go for D. Even if the Asian population was highest, as it is at the moment in the low and the middle group, if they were second place in the high group, if they were finishing about here, you would have to go for D, because you can't assume that you've got the same number of people in each of the three groups. And you have to consider that maybe the high group, just as an example, is weighted more heavily. Maybe there's more people in that group. And if that's the case, then on average, the Asian population might have a lower mean writing score. But, as I mentioned before, because in all three socioeconomic groups, the Asian population is highest, we can say with confidence that the answer here is option A. Question 9. Now this style of graph isn't particularly difficult once you know how it works, but I think there's a big trap that a lot of people fall into, so I'm going to go through it in this question. So in this particular graph, we're looking at sales by region. Now you can see the different regions are given here on the key, so each different color represents a different region. And on the left-hand side, we have the sales, and you can see at the bottom, this is going month by month. Now the big trap here is that people often think you just read off the left-hand side for each of the four, or in this case, the four groups. So in other words, a lot of people think that for January, say, the central region had $350,000 in sales, because that's where the graph ends here. Likewise, the East group had about 250,000 in sales, and the South group had about 150,000 in sales. That interpretation is actually incorrect. What you're looking at in this particular style of graph is just basically the difference in height between the top and the bottom of each of the regions. So in other words, for the blue group, the central region, if we look at January, the top here is at about 350,000, and the bottom would be about 260, 270,000. So the sales for the central region is really just that height there, or that difference between top and bottom of about $80,000. So their sales for January would be about $80,000, not 350. Likewise for the cream or the kind of yellow group here, you don't read off the top. You don't go just straight to the side and say that they had 250,000 in sales. You have to look at the top, which is 250,000, but also the bottom, and the bottom here is at about 150,000. So the difference there is 100,000, and therefore their sales for January are about 100,000. That's the way to read this. So therefore the top line here, the top of the blue, represents the overall sales for all four regions when you put them together. It's kind of the total broken down in that way. That's basically the trap, is that people just read off the side and think that, for example, the central group was the best group all year long because they're on top, and then the second best group for every month was the East group because they're permanently second, and so forth. But it's just a case of they've kind of been layered in a way which shows how they accumulate to give a total. So which of the following is true? The lowest monthly sales achieved by the central region was in July. So central region, we're looking at the blue. And again, this answer focuses in on that trap. We can see that in July, the blue, or the top of the blue here, is at the lowest point that it is in the entire year. For that reason, A may be very tempting. But remember, if we're just focusing on the central region, which is the blue, we're looking for basically the smallest height. So in other words, looking for the smallest gap between the top of the blue and the bottom of the blue. And I would say over the course of the year, that would be found probably here in February. You can see that's quite a small distance, certainly smaller than here in July. And that means that this was the month, February, where the central group or the central region had the lowest overall sales. For that reason, A would be incorrect. Option B, pretty similar. The lowest monthly sale figure for the southern region, so we're looking at the brown group now, occurred in August. So that looks pretty good, because you can see here in August there's a very small distance between the top and the bottom of the brown group. So that represents a very small number of sales. And I'd say that's probably the narrowest distance between the two out of the whole year. We can see it's the brown group here is kind of wider or higher the whole way through, and it's probably at its narrowest in August. So that's why B would look pretty good. Option C, the East region had a sales figure of approximately 250,000 in February. Again, the only reason that would be correct is if you read off the graph incorrectly, as I mentioned before, by just reading off the left-hand side. So you can see February East group, which is the yellow group, that does look about 250. But as you know from before, that's not the correct way to interpret this. And D, the only month where the East region had a higher sales figure than the Central region was February. So we're comparing the East and the Central region, so that's the blue and the yellow. And I would say that the Central region actually had more sales than the East region quite often. So you can see here, the blue is often quite a bit thicker than the yellow. So for that reason, I would say D is incorrect. So the best answer out of those is still option B. That's why it's correct. Question 10. Now there's quite a bit to unpack in this graph. As always, begin with the title. So we're being shown here the prevalence of the 3 most common combinations of 9 selected chronic conditions. And this is broken down by age and the type of chronic condition. And it's in the US in 2000 and also 2010. So I think the first major distinction, or the first major differentiation in this graph is the bottom, age and years. So you can see that on the left here we have 45 to 64, and on the right is 65 and over. That just means that the whole left-hand side of the graph here is showing people in that age range, 45 to 64, and the right-hand side is showing 65 and over. So that's the reason for kind of the two sides of the graph. The next subdivision is based on the combination of conditions. So you can see that's given in this line here. We can see hypertension, diabetes, hypertension and heart disease, hypertension and cancer, and those combinations are given again on the right-hand side. So in other words, you can compare directly those combinations of conditions in this 45 to 64 age group and compare it to the 65 and over group by looking at the corresponding graphs. If we keep moving up, the next division is based on the year. So you can see that for each of the combinations of conditions, we've got both a graph for 2000 and also a graph for 2010. So that helps you kind of track the progress of those conditions over that 10-year period for the same group of people. And just finally, the graphs themselves, you can see that they're broken into a green and a blue component. So looking at the key, the green component is only specified conditions. So that means it's the percent prevalence out of that whole age group population who have just the specified conditions. So in other words, out of the 45 to 64-year-olds in the US in 2000, only 2.2% had both hypertension and diabetes, but none of the other 9 selected chronic conditions. That's the way to interpret that. That blue part there, you can see, is the specified conditions in addition to at least one of the other 9 conditions. So in other words, 2.6% of the US population aged between 45 and 64 had hypertension and diabetes and at least one of the other chronic conditions selected. And that number at the top, 4.8, is just the combination of the two numbers we went through before. So it's the people who have hypertension and diabetes, as well as hypertension and diabetes and another condition, all put together. That's really the way to interpret this graph. It's not particularly difficult, it's more just fiddly, and there's a lot of different parts and subparts to it, so you have to be careful with which part you're reading off. If we go to the question now, what proportion of the American population over the age of 45 had hypertension, diabetes, and at least one other selected condition in 2009 to 10? So what proportion of the American population? That's a good start because we are looking at the American population and we're dealing with proportion. These are all percentages of the total population. So that is proportion as opposed to just a raw number of people. Now the next part is saying over the age of 45. That's not particularly helpful because you can see everyone in the study, or everyone shown in the graph, is over 45. The main distinction here is whether you're over 65 or not. But over 45 is everybody shown in the graph. So we can't really focus in on one particular part of it just yet. But it's asking us for the people who had hypertension, diabetes, and at least one other selected condition. So hypertension, diabetes, that you can see here on the left-hand side of both the two age groups. and we're looking for those two conditions plus one more. So that is the part shown by the blue part of the bar graph, as you can see from the key. And we're looking in 09, 010. So we're just looking at basically this bar graph here that I'm pointing to, and this one here. So this one here represents obviously the 45 to 64-year-olds, and this one is showing the 09, 010. And given we're just looking at people who have hypertension, diabetes, and one other condition, we're really just looking at the blue part of those two graphs. So the 4.1 here and the 10.2 here. Now take a second to just think about what that means. It means that in those who are between 45 and 64 in America at that point in time, 4.1% of people fit that description. Whereas for those 65 and over in America at that time, 10.2% of that population fit the description given in the question. And we're being asked overall for all the people above 45, which of course is both this group and that group, what is the total prevalence in the population? So it may be very tempting to just add up 4.1 and 10.2 to give 14.3 and go for option C. But keep in mind, if we have one group where the prevalence is 4%, roughly, and another group where the prevalence is roughly 10%, if you combine those together, if you combine those two populations, your total prevalence will be somewhere between roughly 4% and 10%. In other words, because you're adding both the people who have it and the people who don't have it in those two different groups, your prevalence will be somewhere between those two figures. You're just averaging out the two groups. So for that reason, the correct answer is A. It's somewhere between 4.1% and 10.2%, which are the two numbers we've been given here. We can't say an exact figure because, again, we don't know the raw number or the distribution of people between these two different parts of the graph. In other words, we don't know what distribution of people are in the 45 to 64-year-old range compared to the 65 and over. So we can't give an exact figure, but we can say it's somewhere between the two figures we've been given here. It's somewhere in the middle of those two. So for that reason, the answer is A. I'm just going to do a couple of quick questions based on a pie chart. We can see in this pie chart we're being shown the pattern of change in asthma severity at a 1-year follow-up. So in other words, it's saying at a 1-year follow-up point, the initial participants had changed in the following ways. So 7.8% had improved, 48.1% were worse, 39% showed no change, and there were 5.2% of people who they couldn't get complete data from. So this 5.2% group could be in any of the other three groups. We just don't know where they belong. So which of the following can be concluded? Well, option A is immediately wrong because of what I just mentioned about the incomplete data group. That means that we didn't have complete data about all the participants. With option B, now the reason why option B may be tempting is because it's basically saying that participants who didn't improve or worsen. So the temptation is to just cut out the improved group here, the red group, and the green one here for the worsening group, and just to look at the remaining part of the pie chart, which together would be about 44.1 or 44.2%. The reason why option B is wrong is because this incomplete data group, that's not the same as no change. In other words, the 5.2% of participants who are represented by this group, some of them may have had improvements, some of them may have had worsenings in their condition. It's just that we don't know. So you can't say as a fact that this percentage of people had neither improvement nor worsening. We know that 39% definitely had no change, but we can't be sure of how much of this 5.2% also had no change on top of it. So option B can't be right for that reason. With C really is wrong because it's outside the scope of what's being shown. It's asking for the percentage who were treated initially, whereas nothing about that is really shown in the table. Certainly the 7.8 figure comes from the improved group, but we can't assume that just that group were the ones who were given treatment and everyone else wasn't. That's just outside the scope. So finally, D, at least 48.1% of people experienced a worsening of asthma severity. So that looks pretty good to me because we have that 48.1% figure here in the worsening group. And we also have the reason why it's worded at least is because we also have this incomplete data group where we don't know the outcomes of those people, but we can assume that potentially some of them also had a worsening, even though we couldn't complete data on them. So that's why it's at least 48.1%, because we know for certain it's 48.1, but it may also be a few more in addition to that from the incomplete data group. So for that reason, D is correct. Another quick question. So if there were 156 people included in the improved group, which of the following can be concluded? So this kind of comes back to the numbers and the mental arithmetic we did before in a previous video. So what it's saying is this red group here, the 7.8%, that represents 156 people. So the step we have to take is to work out, well, if that percentage equates to that number of people, what does 1% equal? And or what does 100% equal? So in other words, how many people are in this entire pie chart based on this assumption, or this fact rather. So if 7.8% represents 156 people, you may notice that actually goes into each other quite nicely. 156 and 78, that's just double. So if 7.8 is 156, what that means is 1% is equal to about 20. If you feel more comfortable, you can round up, so we can say that that's 8%, and that number is 160. That might make it a bit easier. So if 8% is equal to 160 people, just divide both by 8, and you'll get 1% equal to 20 people. So what that means is in this pie chart, 1% is equal to 20 people, and therefore 100%, which is the whole pie chart, would just be, you just have to add on 2 more zeros to get 2,000 people. So there are 2,000 people shown in the whole pie chart. Having done that, if we now go through the answers, the maximum number of people who could have improved at the 1 year follow-up is 240. So 240 out of 2,000 is about 12%. Let's have a look at the numbers now and see if that's true. So the maximum number of people who could have improved, so that's the improved group plus the incomplete data set. So 7.8% plus 5.2%. If we add those two together, you get 13%. So 13% out of a group of 2,000 people would be 260 people, not 240. So for that reason, A is incorrect. If incomplete data here was 4.2%, then if you added the incomplete data and the improved group together, you would get 12%. And 12% of 2,000 is 240, and then A would be correct. But it's just a case of the numbers being a bit off. In this case, because we've got 13% rather than 12. Option B, there were 2,000 people from whom complete data was obtained. Well, that's incorrect because you know that 2,000 people is the total number of the whole pie chart, and 5% of that was incomplete data. So because we have this blue group, that means that we didn't get complete data on all 2,000 people, and that means that B is incorrect. C, there are at least 982 people who are worse at the 1 year follow-up. So that's this group here. So it's the worst group plus potentially some of the incomplete data. The wording is quite good because we have at least, which accounts for that. It accounts for the fact that we know we have the green group who have worsened, but we may also have some people worsening in the incomplete data set. As for the number, 982 people out of 2,000. So try and do the maths on that. I think it's about 49.1%. So again, it's just a discrepancy in the numbers because we have 48.1% here, and this number of people shown in the answer rather is actually 49.1%. So for that reason, option C would be incorrect. And option D, there are at least 780 people who didn't notice any change at the 1 year follow-up. So that looks pretty good to me because the didn't notice any change is the same as no change. And I've got 39% here, and that equates to exactly 780 people. And again, the wording is very good because it has at least, which accounts for the fact that there may be additional people in the incomplete data set to add to the 39% or the 780 people that we know for certain didn't have any change. And for that reason, the correct answer would be D. I've just got 2 more questions in the video, and they're both based on this graph here, which is a little bit unusual. So as always, begin with the title. We're dealing with the death rate from all causes in country X. It's another happy topic. So you can see here, as shown in the title, it's a rate, and that's supported by our units, which unusually are shown in the top left here. It's deaths per 100,000 of the population. So take a minute to think about what that means. It's saying that out of every 100,000 people in that population, this number of people shown by the line graph, so you can see initially it's about 450. 450 people died out of every 100,000. it's not saying the population itself was 100,000, and it's not saying that only 450 people died initially in the country as a whole. It's saying that out of every 100,000, that's the number that died in any given year. Now you can see with this line graph, this is the one I'm pointing to now, that's the one which is showing the true figure for the death rate in each of the years between 1950 and 2010. You can see initially there was this kind of gradual increase until about 1970, at which point it dropped off quite quickly. There's no reason given for that. I don't know if it was a vaccination or a medication or what it was, but obviously there's been this sharp decrease. Now there's two other lines in this graph. We can see that there's a dotted line up here. What that is showing is basically the fact that between 1950 and 1970, the death rate was increasing gradually, as you can see here. It was trending up a little bit. And that dotted line is just saying this is what would happen if that trend was extrapolated between this point here in 1970 and the end point of our graph in 2010. So if that trend had continued until 2010, we would expect the death rate to be around this point here. Now there's also a comment attached to it, which is that more than 1.8 million people would have been expected to have died in 2010 if the rate shown by the dotted line here had eventuated, if it had continued at that rate. So that's what you could have expected had the rate increase shown here had continued after there until 2010. Now the second line here is the solid black one that goes horizontally. All that's showing is the rate in 1970 where it begins. It's saying if that rate at that point in time had continued over that period until 2010. That's all it's showing. And it's saying if that is the case, or if that had been the case, the number of deaths expected in 2010, given that rate and given the population, would be about 1.6 million. Fortunately, we can see that there actually was a big drop-off here, as shown by the line graph. And in 2010, the actual number of deaths, as shown by this comment, is 380,000. So as is given by the comment above, the difference between the actual number of deaths in 2010 and the number that would have been expected had the rate remained constant from about this point here in 1970 is that difference between 1.6 million and 380,000, so about 1.2 million. So it's a bit of an odd graph, given there's a few different lines and extrapolations and kind of comments scattered throughout, but that's kind of the way to interpret this. So which of the following can be concluded about country X? Option A, the death rate will continue to decline after 2010. So there should be a red flag there already, because any answer that asks you to make a prediction about the future is generally wrong, even though the trend is very much downward and quite strongly so over a long period of time. We can't make any predictions about what might happen after this point, so A can't be correct. Option B, the actual number of deaths in 2010, which is, as you can see here, 380,000, was at least 1.4 million less than what we would expect had the rate increase seen prior to 1970 continued. So we're dealing there with the dotted line, because we're dealing with the rate increase extrapolated after that point, till 2010. That's the dotted line there. And as we can see, we can expect more than 1.8 million deaths in 2010 had this rate continued. So the difference between 1.8 million and the 380,000 who actually died is a bit over 1.4 million. So at this point, option B is looking pretty good. That all seems to check out. Option C, approximately 450,000 people died in country X in 1960. So I guess the reason why that's an option is because in 1960 you can see the graph does read off about 450 people out of every 100,000. But that doesn't mean that that number of people died. That's just a misinterpretation of the data. For that to be the case, you need to have a population of about 100 million people. So that's just a case of understanding what we're being shown and understanding that you don't know the number of people who actually died in a given year unless you also know the population. So option C can't be correct. And D, the decline in death rate was due to the widespread use of antibiotics. So it may be true, but again, any option which asks you for a reason why something occurred is almost always wrong. So you really can't say that with any certainty, and for that reason D is wrong too. So the best option out of the four would be B. On to the final question now. It's as much a graph question as it is a mental arithmetic one, so again it goes back to the previous video I mentioned before. This time we're being asked, which of the following is the closest estimate to the population of country X in 2010? So you may have noticed that we're not actually given the population anywhere in the graph, but we are given the actual number or the raw number of deaths in 2010, which is there, 380,000. And we're also given the rate of death, which is out of every 100,000 people. So we can bring those two bits of information together in a way to calculate an estimate for the total population. Now, for those of you who are mathematically inclined, you might have seen this technique, or you probably would have just in high school. What I'm going to do here is write 150, because that's the approximate rate of death we've got here in 2010, if you read it off the left-hand side here. And that is that's 150 people who are dying out of every 100,000 people. So I'll put that over 100,000 as a rate, which is what it is ultimately. I'm going to say that this here is equal to the total number of deaths out of the whole country, because that's what it is. It's a rate. It's showing you a proportion of the population, but that rate is the same as the whole population. So in the whole population, we know that there are 380,000 deaths, and that's out of a total of, well, we're not sure just yet. That's the whole point of the question, is that we don't quite know how many people are in the whole population. So I'm going to put X there. So really these two are equal. We're just seeing that this is a smaller proportion of the total population, but the rate is going to be the same. That's why you can say that they're equal to each other. Now those of you who are mathematically inclined will know how to solve it from here. I won't go into the details of how to do it, but basically we just swap the X and the 150 around, and then we multiply both sides by 100,000. So from there we can just say it's X equals, and then on top we'll have 380,000, and that's times by 100,000. So just add on the 5 additional zeros at the end. And then that's over, remember we swapped the X and the 150, so that's over 150. Now if you look at the answers, they're all very different. There's big gaps between all of them. So that means you can round quite a lot. So what I'm going to do here, just to make it a bit easier with the math, is get rid of the 3 and the 8 in front of here and replace it with 4 and 0. So just changing it from 38 to 40. And on the bottom, instead of 150, given we've increased the top by a little bit, I'm also going to increase the bottom. So instead of 150, I'm going to write 200. So just a small increase there. That should make it much easier again. So all we have to do now is just get rid of the zeros we don't need. So 2 zeros off the bottom, 2 off the top. And then if we're dividing this by 2, that just means that this top number here goes from 4 down to 2. So I'll get rid of the 4 there and just change that to a 2. What that means is X, which remember is our total population estimate, is 200, and just make sure the zeros are right, 200 million. And that would be closest to C. If you're not particularly experienced with maths, if this is a bit confusing, again I won't go into the details of how to do this, and I don't think it will come up in the real exam. But just ask yourself, how many times does 200 go into 400,000? In other words, how many groups of 200 people would I need to make up 400,000 people? The answer there is 2,000. You need that 2,000 times over. And at that point, it's just a case of timesing that 2,000 by the population group you're looking at, which is 100,000. So that comes to the same number we've got down here of 200 million. That's the way to think of it more sort of abstractly if you don't know the maths behind it. Again, I don't think it'll come up on the paper, but they can ask you to calculate from time to time based on a few different figures such as this, so I thought I'd throw it in. And yeah, as I mentioned before, the closest answer out of the 4 here would be C, 250 million. So that would be the correct answer. That's it for this video, and for those of you who have gone through the videos in order, that's the end of the Section 1 series. I just want to say that not every question you'll get in Section 1 will fit nicely into one of these videos. You won't be able to just cruise through Section 1 with all these tips. There'll still be some where you really haven't seen anything like it before, and that's just the nature of the exam. The whole point of these videos is just to give you a few extra tips compared to the other people who haven't prepared as much or haven't seen the videos, and ultimately it's just about getting that slight edge over other people in the UMAT. It's not about getting everything right. That's not really done. People don't do it that way. It's just about being a little bit better than, or a little bit more prepared than the majority. So hopefully when you go through, even if it's just a handful of questions where you know how to approach them through these techniques, I think that'll keep you in pretty good stead. So all the best, and I hope this video helped.